We are starting chapter 2B. Title of chapter 2B is what again?
More derivatives.
More derivatives or more differentiation. We're going to do more. Why does that make sense? Because it's section 2.5 and the test ended at section 2.4. So we're going to do more of chapter 2. I said find dy dx. What's the problem?
There's an x there. X, y.
Yeah. What are we used to having on this side? Or on this side?
The y by itself.
The y by itself. It's not by itself. It's all mixed in. Ah, stink. But hold on. Kyle just said we're used to having the y by itself.
So we get the y by itself.
Look at you guys. You're geniuses. So therefore, if you were doing this last part of chapter, because technically we're still in the same chapter. Anyway, if you were before section 2.5, you'd be like, all right, I mean, it's weird, but I guess you could say that y is equal to, what'd you guys get?
Negative 3x plus 10 over x.
I mean, you could do it that way.
Or that way.
Why would, no. Technically, I'm teaching Algebra 1, and we taught that the standard form of polynomials is descending order. When is there an exception to that? Why did I not write negative 3x plus 10, even though Kyle was right?
You don't like the negative there first?
Maybe I don't like the negative. It's not that I don't like the negative. Can someone reword what Kyle said? I'm just putting the forever cards back up. Sorry, it's kind of annoying.
You like having the...
Yeah, I don't like having the negative come first, if I can help it. If I can help it, I don't like the negative coming first. So therefore, and guys, it's a standard mathematical notation in the sense of, instead of doing, can you think of this? Hold on, close your eyes. Some of you are pretty bad at like visual math. If I said negative x squared plus 4, how would that probably be written? 4 minus x squared, exactly. Negative x squared plus 4, you're not going to see that. You're going to see 4 minus x squared. But what do a lot of students get confused on? 4 minus x squared. Because they're like, I think it's a difference of squares, but the minus is in between the number and the variables. But it's no big deal. Like, whatever direction it comes, it is a common math thing to put the positive number first if it's like a binomial or something. But anyway, Kyle, all that to say, you're right. I just like this better. Then what did you guys do? Why was I hearing quotient rule being thrown around?
Because it would be an easy way.
Because it's a... Was there another way of doing it?
Yes, but...
What would have been the other way?
Split the 2.
Split the 2. Why? What do you mean? What would it become?
So 10 over x minus 3 over x. Or 3x minus.
Yeah. The x's were just reduced. Wait, couldn't we have made this? Are you sure the quotient rule was easier? Depends on your brain. Both of them are going to lead you to the same place. I'll show why I think rewriting might have been easier, but that's okay. Dy dx is equal to bottom d top. Oh, that's a parenthesis. Oliver. Bottom square. Equals negative 3x minus 10 plus 3x. Did you guys distribute the negative and not kill a seal? All over x squared, which equals, you see what I mean by maybe this one would have been a little easier to derive? Bring down the negative 1, make it a negative 2. Dun, 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 that's a 0. Dun, dun. Did you find dy dx?
Yes.
What was the one thing that was weird? At the beginning.
The y.
It was all
The y
jumbled in there.
was, sure, jumbled in. I would say mixed in, but yeah, jumbled in. Ready? The equation was given
Implicitly.
Wow. So, what do you think is at the bottom of the page? Were we able to do this get y by itself way? Yes. Why am I going to say the word but?
I thought there was going to be some forever card involved.
Maybe, maybe not. Does anybody else have an idea besides but? There's a forever. We were able to do this an old-fashioned way, but why is there a whole new section if we can do it an old-fashioned way? There's a new way, but not just is there a new way, there's a need for a new way. What's the dilemma say?
What if mixed up functions are more difficult?
What if that had a y and that had a y squared? We could pull out one y, but you could do a quadratic formula. Maybe there's a way to deal with mixed up functions without having to get y by itself every time. That's section 2.5. Before we hit section 2.5, what to do with mixed up functions, not compositions of functions, but literally mixed up. Y is entrenched inside, is implicitly given with x's and y's all mixed up. That was kind of how we talked about it in pre-cal. Let's go talk about AP Classroom. So last night you were supposed to be pondering the ones that you missed in AP Classroom. I think we only looked at one yesterday, right? The estimating the derivative one. But there were still quite a few that we didn't do so hot on. Does anybody have a particular number they're like, please, can we talk about? Kathleen? Number 8. Okay, help me out. There's no numbers on this, which is a little annoying. 1, 2, 3, 4, 5, 6, 7, 8. I think it's this one. The 5 people that got it right, whether or not you aced it, knew what you were doing, or you guessed right. So congratulations, Adam, Alfredo, Andrea, Vicente, and Vico. But let's go see what the question was. The graph of f prime. Can I zoom this? Hold on. There you go. Oh, no. Are there 5 answer choices? No, just 4. When you guys open it, does it give you this little description as to one? Okay. We have the graph of who or what? F prime. Who is the derivative? Wasn't there a homework problem where we were given a graph of a derivative? Maybe it was a workspace problem. Anyway, there was one. You were supposed to write notes and highlight it all up. Anyway, the graph of f prime, the derivative of a function, is shown above. The points 2, 6, and this is weird because these aren't points on the f prime graph. Who are these points of? They're giving us weird clues. Which of the following is an equation of the line tangent? The line tangent, as soon as you... Now, here's a cool thing. I was at a friend's house last night. She teaches, or she's on sabbatical. She just had a baby. Super cute. She fell asleep on it anyway. It was really cute. But, coming back. She was talking about her calculus class because she has a sub in her classroom right now, and we were talking about AP Classroom, and she hasn't figured it out because it just, you guys know, came out this summer. She was like, how is it? I was stealing questions from it, but I haven't been able to assign it to the kids. She literally had her kids for 2 weeks, 3 weeks, and then she went on maternity leave. And someone else is subbing for her. But anyway, she was like, how is it? I've been doing this thing, and she showed me what she did, and what she has is in these interactive notebooks. Maybe someday I'll be cool like that, but not right now. But she has all these practice AP multiple choice that she's kind of taken from tests and tweaked a little bit by changing numbers and anyway made it her own. But after every single practice multiple choice, she has this that the kids have to fill in. Every single problem. She has concept covered / forever card. She started teaching a little bit after me. She stole the forever cards from me, but it's okay. I stole my forever cards from my high school calculus teacher, but calculus wasn't a thing when I had her. It was pre-calc. But coming back, I stole it from her. So, forever card. She has the same terminology as me. And then she has a little bit more that they have to fill in. But she has this question after every single practice AP problem that she ever gives them. Why? Why would she have kids write this after every single practice AP problem that they do?
They know the formula for the day.
Yeah, there's a big picture behind every single problem, no matter how weird, no matter how crazy, no matter. There's some sort of concrete concept or forever card. There's some big idea they need to go back and review or remember or reuse. Oh, I remember. This one is the first step. What's the first thing that you're supposed to do? There's one more. There were 3 things. I don't remember. Anyway, sorry, I was distracted. I had a baby in my arms. But coming back. Question, what's the big idea for this one? Tangent line. Right? We could actually write the word if we want. We could say tangent line or the equation of the tangent line. There's a forever card for tangent line, true? And for those of you cute ones that were supposed to on a recent forever quiz, give the equation of a tangent line. Why is this not it? Awkward. Because it was on the wall and some of you used it. Why is this not your equation of a tangent? That's parametric. That's given an x of t and a y of t. That's given a t to plug in. We're not given t's. What's our first step in this one? What are we supposed to do anytime we see a tangent line? Y minus y1 equals m times x minus x1. But we're supposed to know who this guy is. There is another form, and it's y minus f of c equals f prime. I don't know why it's shaking, just hang in there. X minus c. We're given an x. And we're supposed to, if we need to, go find the y, because we have an f of x, not an x of t, y of t. And we're supposed to go find the derivative by f prime of x, not derivatives of parametric functions. Whap, whap, whap. Good try. Yes, that one was up on the wall the other day for your forever quiz. That was nice. But coming back, it was too late. People had already seen it, so I just left it up when I noticed it. But coming back, so why did I write that for our first step? What do they want? X equals 2. True? That's all we have to do is say, oh, sweet. So y minus f of 2. Hey, they gave us at 2 the f of x is, or the y is 6. True?
Yeah.
And then we know x minus 2. What's the one thing that we're missing?
Or f prime of c.
And f prime of 2, we're supposed to be like, f prime of 2 is 5. Dun, 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 dun. Oh, wait, we still have to simplify. That's okay. Look at all the multiple choice answers. What did they do? They got y by itself. So therefore, to get y by itself, we can go ahead and be careful of your math, but you end up with a 5x. Couldn't you go through and say any ones without a 5x are going to fail? Well, I guess it'll only, oh, hey, that gets rid of 2 answer choices. So we have our 5x, and we have minus 10 plus 6, which is minus 4. Dun, 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 beep. Kathleen, we good? Guys, they love to force you to know the ideas without giving you the actual functions. Now, they sometimes give you the functions. You have to know how to be able to take derivatives. But we said that this is concept heavy. Why? They're going to give you graphs of derivatives or tables of different points, or they're going to give you little clues, and you're going to have to know how to put them all together. But what's the first step you need to think about with any AP problem? What's the concept? What's the forever you can attach? Then, how do I start? And then, let's go. Okay, anything else besides number 8? Come on, we did some, well, I don't want to say we did some bad work, but we did make some mistakes. We did get stuck on some. We were just looking at some of those stats, right? Is there anything else we want to see? Kyle?
I think it's number 10.
Number 8 was the second one. Nope, number 8 was this one. 9, 10.
It might have been that one.
Let's see.
Yes, this one.
Ah, the 1, 2s, and 3s. They love those two. The 1, 2s, and 3s. Let me zoom in just a little bit. Which of the following statements, if true, if true, can be used to conclude that f of 2 exists, and we actually have some multiples? Oh, Steve. Okay, first of all, before we even go there, we need to actually deduce what's going on here. Where do you guys see the terminology f of something exists? It's the at. The first point of the definition of continuous. That's the forever card, that's the concept covered, yeah? Okay, so if we look at, why isn't this working? If we, the at exists. I give up. The at exists. If the limit exists, does the at have to exist? Wait a minute, if that's the at, what's this? The approach, remember? Come on, right? We have the at, the point filled in, and we have the approach, what we're getting closer and closer and closer to. If the approach exists, is the at always there?
No.
No, remember, if there's a hole, the approach can still exist, right? So forget that, number 1 is a no. So, hey, don't we have 50% chance of getting it right? For any standardized test, for any multiple choice test, you want to narrow down. True? Okay. So, first of all, the limit, the approach, does not mean the at is there. That's why the definition of continuous has these as 2 separate points, right? But wait, number 2, if f is continuous, doesn't that mean that condition number 1 was met? Sweet, that's a must. And why is number 3 also something, if true, that can be used to conclude that f of 2 exists. If the function is differentiable, what does that mean? It must be continuous. Do you guys see why I have that forever part? If it's continuous, it may be differentiable. If it's differentiable, it must be continuous. Differentiable must be continuous, that exists. Sweet. Him and him, 2 and 3. Anything else you guys want to see? Are you sure? Wyatt.
Number 2.
Thank you, bud. That was one of our lowest. I actually think that was our next lowest. Yeah. Our 3 people, Kyle, Vicente, and Biko. Nicely done. Let's see what was going on. Estimate the derivative. Hey guys, if we're estimating a derivative, can we just go ahead and really quickly remind ourselves of what a derivative is? Oh, stink. F prime of x equals the limit as h goes to 0 of no. No, that's the technical definition, which is good for us to know. But let's think about the descriptions of the derivative. Okay? Same card at the very bottom of the card. What are the verbal descriptions of a derivative? A derivative can be what? No? Right here.
What did you ask?
Descriptions, not the technical definition, but the descriptions. Who's the derivative?
A tangent line.
Slopes of the tangent. Slopes of the graph.
And rate of change.
Instantaneous rate of change. So, guys, hold on. Check it. What have they given us in this problem? A little baby table. Come on, right here. Little baby table. That's what's given. And, they gave us a b to the u. Now, for whatever reason, I think it's because I was gone last Monday, not yesterday, but last week. Anyway, when you guys took the notes on b to the u, did I say bulimbu? I didn't in the video? Someone said in the video I did. Yeah, the derivative of boo is bulimbu. Just in case you didn't have that memorized, but the derivative of b to the u is b to the u, ln of b times u prime. Boo, boo, limba, boo. Anyway, what are we supposed to do? Approximate. Anyway, approximate f prime of 0.5. True? Well, who is f? How do I think of his prime? Oh. And then I plug in 0.5. Guys, this is an easy problem. I wonder why they're saying estimate, because it's not a big deal. I can actually do this one, can't you? Because the derivative of 2 to the u, b to the u, is 2 to the u, b to the u, times ln of b, ln of 2, times u prime, 3x squared. This is easy. Was it easy? What are you supposed to do once you have f prime of x? Oh. What's the problem with plugging in 0.5? If the values in the table are used to approximate f prime of 0.5, wait a minute, they're not just plugging in 0.5? What is the difference between, struggle, did you guys realize what you were actually supposed to be doing?
Subtracting.
What is the difference between, good. Difference between subtracting the approximation and the actual. So they're saying we know you can find the actual. Hopefully you can find the actual. Look how much math went into knowing that rule. You had to know the chain rule, had to know the derivative of b to the u, had to know what a derivative was. Anyway, we can find that in our calculator. This is a decimal question, so calculators are allowed. You could have plugged in 0.5 to the derivative. You can actually use your calculator to find the derivative, to be totally honest. You didn't even have to find it yourself. But, coming back, well, how would they have used this to approximate? Would they have plugged in that? No? Would they have plugged in? No? Verbal description of a derivative. It's a slope. It's a rate. What's the other way of doing a slope or a rate without finding a derivative? Not instantaneous, but average. So they said, what if they had done the average? What if they had done the rate the other way? A way of approximating a derivative with a table is, okay, it's a slope, I'll do the best I can, 1/2 is in between, so maybe. They would have done the average rate, what they were basically saying, find the average rate minus the instantaneous rate. Do an approximation way of finding a slope minus the way of doing the actual tangent slope. That's what they were asking you to do. So at the end of the day, you would have had to go ahead and plug into your calculator 2 to the, oh no, we actually have the value, that's easy. So you could have gone ahead and done 2 minus 1, which is 1, all over 1 minus 0 is 1. Oh, that's easy. So 1 over 1 would have been my approximate or my average minus, and then we would have plugged into this dude, which would have been something kind of gross. What did you get for that one? 0.567. You guys see how 0.567 was chilling right down here? Bummer. That was the F prime. That's not what they were asking. Even though if you had seen this fast, you're like, I know what I'm doing. Done. And you would have known some good calculus to get there, but it wouldn't have been right. They were asking for the difference. What's 1 minus 0.567? 0.43. Good question. All right, last call. Going once, going twice. You sure? All right, guys, is it a valuable thing to go back over these if you haven't yet and see which ones you missed and try to read those little descriptions at the end if you guys didn't notice, if you didn't go on, if you didn't check it out last night? They do try to give you at least a little bit of explanation as to why, okay? And actually, well, I don't know. Do they give this to you guys too? They're really cool, like, hey, what was the topic, and let's go look at other. No way. That's pretty cool. Yes, the website is kinky. Yes, the website has some issues. However, they have a lot of resources. Oh, now it all shows up. That's random. All right, let's go ahead, and we have some work to do, especially for my poor little juniors that are going to be gone tomorrow, and say, what do we do with more mixed up functions? What do we do with more mixed up functions? All right, let's go forward. Woo! What about this guy?
Good morning.
Ah! Let me pause the screen. I'm going to go back and try to get rid of the random writing that randomly showed up. It showed up late on my screen. You guys, write down this example and start pondering, what could you do if you needed to get rid of or get y by itself? Proper terminology, isolate y. Could it be possible? Ponder it. Could it be possible? Those of you guys that are watching me go all over the place, I am so sorry. There we go. Can you guys get y by itself?
I have no idea.
Y squared minus 3xy plus 5x equals 10. What if we moved that to the other side?
Cool.
You just square root both sides. You never watch that.
That's disgusting.
But the problem is, if you wanted to square root both sides, wouldn't you, for that to help, wouldn't you have had to, negative, move
Wait a
everything?
minute.
And then what just happened to,
Divide the y?
Can you divide it and then?
No, that's killing something.
okay, divide what? Right now?
No.
If we divide the y here,
Aren't
What's
you
the
killing
problem?
something? Yeah.
so he'd be fine, but what's wrong with these guys now?
I made it more complicated.
Right? Wait, more ideas. What else can we do?
Oh my goodness.
Because it's a quadratic of y's.
Quadratic.
But how are we going to factor 5x and 3? But what we could do, you ready? You
No.
don't have to do this unless you want to. You can just watch. You could get y by itself, but the way to do it. Woo! Look at that one.
Wait, what?
That backward, what was it called?
Woo! We are completing the
Oh,
square.
I never got that.
Because you would take the middle term, you would divide it by 2, and you would square it, and you would end up with 9x squared all over 4 on both sides.
Oh.
You would then be able to do y whatever this guy is, minus 3x over 2 squared equals 10 minus 5x plus 9x squared all over 4. Then, John, we could do your plus or minus square root dealio. Here we go, and here we go. And that would actually end up with, well, it'd be an absolute value. So we'll throw maybe the plus or minus here to forget the absolute value. And then we could say y is equal to 3x over 2 plus or minus square root of 10 minus 5x plus 9x squared over 4. Woo! What do you still have to do? Ah!
Oh boy.
Is this the preferred way?
No.
No.
Definitely not.
Could I have gotten y by itself even in something like this? But there are ones where I can't. So, even though we could, you're welcome, let's not. So, another way of looking at it, ready? Can you guys give me that exact same function over again?
Y squared minus 3xy plus 5x. Okay.
dy dx means you're taking a
Derivative.
So, the other way of looking at it is dy dx is the same thing as ddx of y, which we can technically do even if y is not by itself. We just need to take a derivative of what, you may say? Of everything. Of one side and the other. Of one side and the other. Technically, every time you were doing a dy dx or finding a dy dx, if y was by itself and y was something easy, every time you wrote dy dx is equal to 2x, what you were actually doing was taking a derivative of both sides. You were taking a derivative of y, and you were taking a derivative of x squared. Derivative of y is dy dx. Derivative of x squared is 2x. You were technically always taking derivatives of both sides. So why not just take the derivatives of both sides right now? But we have to think about, well, how on earth would we take a derivative of y squared, of u squared?
Is it just 2y?
Almost.
Oh.
Why am I doing a times?
Because it's chain.
Chain rule. Why is it chain rule? What's the derivative of the outside? Bring down the 2, make it a 1, keep it the same. True? What does chain rule say we have to do next?
Multiply the inside.
What's the derivative of y?
What?
What?
God, computer is that?
Derivative of y squared is 2y dy dx. Just think of the page before, completing the square. We don't want to do that. It was gross.
True.
2y dy dx, if we can figure it out, sounds a lot nicer. Now, if I were you, get out a highlighter, because this next one is where so many people make mistakes. This next term. Why do so many people make mistakes on this next term?
Because they forget.
They forget what rule?
Product rule.
Product rule. 3x times 1. 3x times 1. I have to do a product rule. Now, why is it dangerous that I just boxed inside the subtraction?
You can't forget to distribute it.
If I don't distribute it, I'm in trouble. So we have options. You could either have minus, you're going to put the whole product rule right there and not forget to distribute, or couldn't you change subtraction to adding the opposite and just group the little negative in with the 3x?
Yeah.
Now it's up to you guys. I don't care which way we go. Which way do you think you would naturally think of? Boxing the negative and using it in the product rule, or having the subtraction on the outside? Okay, I don't know. I think most of you would just naturally do this and you would mess it up, just to be honest. And I know that's kind of a pessimistic view, but I've graded enough calculus tests to know. But if you want to start trying to bring it in, it'll be a bit safer. It'll be a bit safer. So let's go ahead and try to bring it in, even though I think most of you will do it the other way. If you would, just try it, the minus, the big old parentheses. The nice thing is, this way we can say second d first, which is going to be y times a negative 3. Wait, why don't we do chain rule when we do box prime? Technically, it's a negative 3 times a u. Derivative is negative 3 times u prime, but what would be the derivative of
1.
x?
1.
And more specifically, dx dx. Whoop!
Excuse me?
d dx of x is dx dx, but what is dx dx?
Oh.
Which is why we never have to write it. We could. I'll put it there just so you know what we're doing. But it's going to go away in just a second. So I have second d first plus first d second plus first. See how they both have a negative? That negative would have had to distribute. First d second. What's the derivative of just a y?
d dx. dy dx.
Whew, it's getting long. I'm not done yet. What else do I have to do?
Take the derivative of
Check. Ah, derivative of 5x. 5. You could write dx dx. Do you really need to?
No.
Equals. Careful. The second most common mistake in this entire problem. 0. A lot of people are just so tired of doing the rest. They're like, equals 10. Equals 0. Derivative of any constant, right? Okay, so all these dx dx's, it was just to prove a point that technically we're doing chain rules every time we take a derivative of an x term also. You just don't see it because the u prime is just 1. But all we have to do now is, well, wait a minute, what were we supposed to solve for? We were supposed to find dy dx. Well, that's a problem. Don't we have a couple of them?
Yeah.
What do we do whenever we want to solve something but it's in multiple places?
Factor.
Factor. Do you see it? I can move this 5 to the other side. I end up with negative 5. That's no big deal. He doesn't have a dy dx, but why am I going to put big old parentheses with a dy dx right here? What can I rewrite first? Uh-oh, hold on. He didn't have anything either. Apologies. He could have gone over there. But who did have a dy dx? This guy? And this guy. You guys agree?
Yep.
I'm going to go ahead and get rid of these little dx dx's because frankly they're just making everything look gross. So we had second d first plus first d second plus 5 equals 0. There we go. So I got to subtract the 5, he didn't have a dy dx. I got to add the 3y, he didn't have a dy dx, but my other two did have a dy dx. And I say, great, get all the terms with dy dx's on one side, pull out the dy dx, and then all I have to do is divide. So then my other derivative would be dy dx is equal to, putting the positive first, that's just nice, and it's descending order. Now, what's very, very different from this guy than the one that we would have found if we had derived that nasty chain rule function on the page before? You guys can tell these are going to look way different. I haven't even derived him yet, but I would have had to keep going, right? Why would they have looked so different? Does that mess everything up? Am I wrong?
No.
No, but why? Yeah, this one would have only been in terms of x. This one's in terms of y. If I would have wanted to compare the two, if I would have taken this derivative, like that would have been 3/2, and then I would have had to bring down a 1/2, negative 1/2 times u prime, and simplify it. I would have had to get the y by itself from over there and plug it in, plug it in. This one would be really nasty too if it was in terms of x. Now what's the nice thing? Do you guys remember just a second ago I closed it out? Kathleen, your question, the tangent line. Do you remember how we had it in the form of y minus y1 equals m times x minus x1? And I looked at the multiple choice answers and what did I see? How are they all written? Y equals. The y was gotten by itself. I used the multiple choice to know where to go. Does that make sense? So what would we do if we had something written nasty like this and we had gotten a derivative? Time out. Go use the multiple choice to know whether you're done or whether you keep going. Does that make sense? What's your guys' version of multiple choice in homework when it's not a multiple choice question?
What the back of the book says.
Look at the back of the book for the odds and for the evens. You're like, well, based on what I've been seeing on the odds, I think I'm good. Does that make sense? And you come to class and see if you can make it match. It's all about making it match. Long story short, which one looks better in your eyes? Doing all this and then deriving, or going like that?
That one.
That's why it's called the new way. But here's the crazy thing, is it technically a new way? No. We've been doing it all along, you just didn't know it. Derivative of y is 1 times dy dx. Derivative of x squared is 2x times dx dx. We were just doing shortcut rules without fully understanding exactly what we were doing. Implicit differentiation means take a function that's implicitly derived, or implicitly stated, I apologize, and derive it as is. So forms of functions, we have explicit ones that are like y equals f of x, aka y is isolated. And it's a function in terms of x or t or theta or whatever they want it to be. Implicitly defined functions are going to be basically f of x, y, where we have x and y's, kind of like how Kyle put it, all mixed up. But you said jumbled, right? All jumbled, all mixed up, all together. Long story short, y is not isolated. And possibly is not, and possibly cannot be. So if it is not, and it possibly cannot, well, here's the nice thing, guys. If they're giving you an implicitly defined function, they're probably meaning for you to derive it implicitly. I know that I had you get y by itself at the very beginning, but that was just to prove sometimes we don't have to use implicit differentiation. But if the function is implicitly stated, they expect you to do implicit differentiation. So I'm going to put over here for our new method, I'm going to say, okay, it's kind of a different thought process, but it's not really. Because even when we had implicitly, no, they weren't implicit, explicitly defined functions, when we took a ddx, when we were trying to find dy dx, we were technically deriving both sides. And we were getting derivative of y is 1 times dy dx equals f prime of x. So even though you've been doing this for a while, the part that's new, well, I guess, is just where did this come from? Oh, ddx of and ddx of. So what's different for us now is we're just going to be deriving, like this, both sides of an equation where y might not be by itself, so it might not be so clear-cut. It might not be so straightforward of, yay, dy dx equals. It might be mixed in. It might be mixed up. But no big deal. If it is all mixed up when you go to take that d dx, what do? Collect all the dy dx's on one side. Collect them all. Move all the others to the other side. Factor out a dy dx out of the side with all the dy dx terms, and then get them alone. Now, that sounds so nice and neat and simple, and it worked a second ago. The problem is, I may as well tell you now. Oh, we already did that one. That's no fun. Let's get rid of him. We just did him a second ago. There are going to be harder problems. This is just a quick reminder of technically we've been doing it all along. Because even when we're doing things like ddx of x squared, we were technically doing a chain rule. So all that changes if we do something like ddx of y squared. With an x, this part just cancels out. It doesn't matter, so we never write it. But if we have a y term, we're going to have to keep the dy dx because they are not the same. I can't just reduce away like I did up here. But underneath the harder problems, I would rather show you this as an example. But for those of you that are going to be gone tomorrow, because some of you might be playing with homework tonight before or after you watch the video, watch out. For substitutions.
Yeah.
made with the original function in the derivative. What I mean is, remember how we had those derivatives with like trig properties, like sine of 2x, and they like plugged it in, and you're like, what? How did you change the derivative to look like that? And it was really a property? The one weird thing that can happen is you have your dy dx, it has all these terms, and all of a sudden it magically becomes something else. They looked back at whatever they were given originally, and there was a substitution that could be made. But it's okay. It'll be like one or two homework problems. Other class members do check out the video tonight and be ready. The rest of you guys, I'll see you tomorrow, and that homework is due on Thursday. Bye, guys. Good work today.